Hello engineers. Welcome to Civil Engineering Infrastructure. Today we are starting Part-4B of IRC 37 Flexible Pavement Design. This part is the most important revision section of the entire series. Here you will learn how to revise the entire subject, how to prepare for the interview, and how to achieve complete mastery. Part-4B we will cover slides 36 to 40. This section consolidates the entire learning. Now let us understand its structure. Interview questions for highway engineering will be in slide 36. This will strengthen your technical preparation. Slide 37 will contain Viva questions with answers. This will improve your concept clarity. One short revision will be done in slide 38, where the entire syllabus will be revised in a quick format. Mnemonics and memory tricks in slide 39, so that the concepts are easily remembered and can be recalled quickly. Slide 40 will contain the final master summary, where the entire subject will be available in a concise form at one place. Now let's talk about learning outcome. After this part you will be interview ready. You will be able to understand concepts clearly. You will be able to revise fast. Memory recall will improve. And you will be able to master the entire pavement design subject. Understand this flow. Interview preparation comes first. Then comes concept clarity, where fundamentals are strengthened. After this comes quick revision, where the entire syllabus is revised quickly. Then come memory tricks, which helps in fast recall. And finally comes the final summary, which gives complete understanding. Now an important engineering note. Revision is what converts knowledge into confidence and performance. Hello engineers. Welcome to Civil Engineering Infrastructure. Today we are starting Part-4B of IRC 37 Flexible Pavement Design. This part is the most important revision section of the entire series. Here you will learn how to revise the entire subject, how to prepare for the interview, and how to achieve complete mastery. Part-4B we will cover slides 36 to 40. This section consolidates the entire learning. Now let us understand its structure. Interview questions for highway engineering will be in slide 36. This will strengthen your technical preparation. Slide 37 will contain Viva questions with answers. This will improve your concept clarity. One short revision will be done in slide 38, where the entire syllabus will be revised in a quick format. Mnemonics and memory tricks in slide 39, so that the concepts are easily remembered and can be recalled quickly. Slide 40 will contain the final master summary, where the entire subject will be available in a concise form at one place. Now let's talk about learning outcome. After this part you will be interview ready. You will be able to understand concepts clearly. You will be able to revise fast. Memory recall will improve. And you will be able to master the entire pavement design subject. Understand this flow. Interview preparation comes first. Then comes concept clarity, where fundamentals are strengthened. After this comes quick revision, where the entire syllabus is revised quickly. Then come memory tricks, which helps in fast recall. And finally comes the final summary, which gives complete understanding. Now an important engineering note. Revision is what converts knowledge into confidence and performance. Slide 36. Interview questions for highway engineering. Now we come to the most important part. Interview questions for highway engineering. This slide is to test your concept clarity and practical understanding. एक introduction. Highway engineering interviews mainly focus on pavement design, construction practices, material testing, IRC codes and site experience. If your practical understanding is strong, then it becomes easy to clear the interview. Engineering note. Concept clarity plus field knowledge is the key to interview success. 2 basic highway engineering questions. What is flexible pavement? ANS. It is a layered pavement system in which the load is gradually transferred through layers to the subgrade. What are the layers of flexible pavement? ANS. Bituminous concrete, dense bituminous macadam, wet mix macadam, granular sub-base, subgrade. This sequence is very important for load distribution. 3 IRC related questions. What is IRC 37? Is a guideline for flexible pavement design in India. What is MSA? ANS. Million standard axles represents cumulative traffic loading. What is the importance of CBR? Indicates subgrade strength and controls pavement thickness. Engineering concept. Low CBR means thicker pavement required. 4 construction related questions. Why is compaction necessary? ANS. Compaction increases density, improves strength and increases durability. Q. What if the compaction is bad? ANS. Rutting will increase. Settlement will happen. Pavement life reduced will be. Cracks will develop quickly. Curing necessary in CTB? ANS. Proper curing is essential for hydration and strength development. 5 material testing questions. What are the tests on aggregate? ANS. Aggregate impact value. Los Angeles abrasion test. Water absorption test. Flakiness index. What is Marshall stability test? Measures the strength and deformation resistance of bituminous mix. 6 pavement failure questions. What is fatigue cracking? ANS. Repeated loading causes interconnected cracks to develop. Q. What is rutting? ANS. Permanent depression in wheel path. Why are potholes formed? ANS. Water infiltration. Weak layers. Traffic loading. Untreated cracks. Engineering warning. Water is the biggest cause of pavement deterioration. 7 overlay and maintenance questions. Q. What is overlay? ANS. An additional layer over the existing pavement which improves its strength. What is reflective cracking? ANS. Cracks in the old pavement propagate into the new overlay. 8 drainage related questions. Why is drainage necessary? Prevents water infiltration and protects pavement strength. What are the effects of poor drainage? ANS. Subgrade weakening, cracking, rutting, reduced pavement life. No site practical questions. What are the common problems in bituminous work? ANS. Segregation, low compaction, temperature loss, improper joint finishing, surface undulation. What precautions should be taken during rainy season? ANS. Avoid paving in the rain. Dry surface maintenance do. Protect the material from moisture. Ensure proper drainage do. QULITY control questions. What are the important QA/QC checks? Ans. Density testing. Thickness checking. Temperature monitoring. Graduation testing. Surface smoothness. एक highway machinery questions. Which rollers are used in pavement construction? Ans. Vibratory roller. Tandem roller. Pneumatic tire roller. What is the function of sensor paver? Maintains uniform thickness and smooth surface. एक दो advanced technical questions. Why are shoulders important? Provides lateral support and improves pavement edge stability. We do. What is CTB? Gives higher stiffness and better load distribution. एक तीन practical site observation. Weak shoulders cause edge cracking. Improper rolling density reduced does. Excess moisture weakens the layers. Delayed maintenance increases pavement distress. एक चार interview tips. Keep the answers short and clear. Technical terminology used do. Please provide site examples. Connect concepts with practicals. Keep quality control knowledge strong. एक पाँच rapid fire revision. MSA means traffic loading. CBR means soil strength. Fatigue means crack resistance. Rutting means deformation. Density means compaction control. Drainage means pavement protection. Quality control means long pavement life. Final message. To clear the interview, practical understanding is more important than theory. Understand the concept. See the site. Follow the standards. Only then will you become a confident civil engineer. SLID 37. Viva questions with answers. So friends, now we have reached a very important and interview-focused slide. This slide is especially useful. Highway Engineering Viva. Site Engineer Interviews. QA/QC Interviews. Freshers Technical Preparation. Highway Project Discussions. Important Viva questions of flexible pavement and highway engineering are given in this slide. And their direct technical answers have also been explained. So let us understand the complete Viva revision step by step. 1. Keycap Introduction to Highway Engineering Viva. Viva questions mainly test conceptual understanding, practical site knowledge, IRC specification awareness. And it is very important to give practical examples along with clear explanation. See the engineering note below. Strong fundamentals help answer unexpected technical questions. And this is the most important key of Viva preparation. Now let us look at the second section. दो basic pavement Viva questions. Q1. What is flexible pavement? Answer. Flexible pavement is a multi-layer pavement system where wheel loads are gradually distributed to lower layers. Now look at the pavement layer diagram on the right side. Typical pavement layers are 1. Bituminous concrete, 2. Dense bituminous macadam, 3. Wet mix macadam, 4. Granular sub-base, 5. Subgrade. Now let's look at the next question. Q2. What are the major layers in flexible pavement? Answer. BC layer, DBM layer, WMM layer, GSB layer, subgrade, and this is the standard IRC pavement composition. Now let us look at the third section. 3 IRC and design questions. Q3. What is IRC 37? Answer. Is the guideline used for flexible pavement design. Q4. What is design traffic? Answer. Design traffic is the cumulative axle loading expected during the pavement design life. Q5. What is MSA? Answer. MSA means million standard axles. Now see the engineering concept below. Higher MSA. Thick pavement. And this is the basic concept of pavement thickness design. Now let us look at the fourth section. 4 soil and CBR questions. Q6. What is CBR? Answer. CBR means California bearing ratio. It is used to determine subgrade soil strength. Q7. Why is CBR important? Answer. Pavement thickness depends on the subgrade CBR value. See the engineering note below. Weak subgrade requires stronger pavement structure. That means, in case of low CBR, pavement thickness has to be increased. Now let us look at the fifth section. 5 construction-related Viva questions. Q8. Why is compaction important? Answer. Improves density, strength and pavement durability. Q9. What happens if compaction is poor? Answer. Rutting develops. Settlement occurs. Cracks form early. Pavement life decreases. And this is the direct result of poor field execution. Q10. Why is temperature control important in bituminous work? Answer. Proper temperature good compaction और strong bonding ensure करता है and creates improper temperature segregation and weak bonding. Now look at the right side highway construction images. Paver machine, vibratory roller, tandem roller, water tanker, and these are common highway construction equipment. Now let us look at the sixth section. 6 material testing Viva questions. Q11. What tests are performed on bitumen? Answer. Penetration test, ductility test, softening point test, viscosity test. Now let's look at the next question. Q12. What is Marshall stability test? Answer. It evaluates the strength and deformation resistance of the bituminous mix. And this mix is used to check the design quality. अब राइट साइड लैबोरेटरी टेस्टिंग सेक्शन देखिए. CBR टेस्ट, मार्शल स्टेबिलिटी टेस्ट, एग्रीगेट इम्पैक्ट टेस्ट, लॉस एंजेलिस अब्रेजन टेस्ट, ग्रेडेशन एनालिसिस, bitumen tests. And all of these are important parts of highway laboratory quality control. Now let's look at the seventh section. 7 pavement failure Viva questions. Q13. What is fatigue cracking? Answer. Interconnected cracking caused by repeated wheel loading. Q14. What is rutting? Answer. Permanent deformation in wheel path area. Q15. What causes potholes? Answer. Weak pavement layers, traffic loading, surface cracking. अब नीचे engineering warning देखिए. Water accelerates pavement deterioration rapidly. 8 overlay and maintenance questions. Q16. What is overlay? Answer. Overlay is an additional pavement layer which is provided to strengthen the existing pavement. Q17. What is reflective cracking? Answer. Cracks from old pavement नई ओवरले लेयर में अपवर्ड प्रोपैगेट होते हैं और यही ओवरले डिस्ट्रेस का कॉमन इशू है। अब 9th सेक्शन देखते हैं। नो ड्रेनेज एंड शोल्डर क्वेश्चंस। Q18. Why is drainage important? Answer. Drainage protects pavement layers from water weakening. Q19. What is the function of shoulder? Answer. Shoulders provide lateral support and improve pavement edge stability. And poor shoulder condition can create edge cracking. अब 10वां सेक्शन देखते हैं। CTB and stabilization questions. Q20. What is CTB? Answer. CTB मतलब cement treated base. Q21. What are advantages of CTB? Answer. Higher stiffness, better load distribution, reduced pavement thickness, improved pavement life. And this is the main advantage of stabilized pavement structure. Now let us look at the 11th section. 1 Quality Control Viva questions. Q20. What are major quality control tests in pavement construction? Answer. Density testing, thickness checking, graduation testing, temperature monitoring, smoothness checking. Now let's look at the next question. Q23. Why is density testing important? Answer. Ensures proper compaction and pavement strength. And inadequate density becomes a major reason for pavement failure. Now let us look at the 12th section. 1-2 Machinery related Viva questions. Q24. Which rollers are used in pavement construction? Answer. Vibratory roller, tandem roller, pneumatic tire roller. And different rollers perform different compaction functions. Let us look at the practical site observation section below. Poor drainage weakens subgrade. Low density creates rutting. Improper joint construction causes cracking. Segregation creates weak pavement zones. And these are frequently asked in actual site observations interviews. Now let us look at the Viva preparation tips section. Answer briefly and clearly. Use technical terminology properly. Explain site examples. Relate concepts to pavement failures. Keep practical construction knowledge strong. And this Viva improves confidence. Now let's look at one short revision below. Flexible pavement. Layered pavement system. MSA. Traffic loading. CBR. Soil strength. Compaction. Pavement strength. Drainage. Pavement protection. CTB. Stabilized base layer. And these are the most important Viva concepts of flexible pavement engineering. If this CIIRC 37 complete series looks useful, so do subscribe to the channel. And now on to the next slide. We will go over the final quick revision master summary and complete flexible pavement revision. SLID 28. Construction considerations. So friends, till now we have understood pavement design, overlay, shoulder support, and rehabilitation concepts in detail. But now we will understand that most important factor can make even a good design fail. And that is construction quality. Because a very important thing is said in highway engineering. Good design fails if construction quality is poor. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. एक Introduction to Construction Considerations. Proper construction practices are very important to achieve vehicle strength, durability, and long service life. If the construction quality is poor, then the pavement will soon show distress, as cracking, rutting, settlement, surface failures. See the engineering note below. Good design fails if construction quality is poor. And this is the biggest challenge in practical projects. Now let us look at the second topic. The importance of construction. How does construction quality affect pavement performance? Proper layer bonding, uniform compaction, adequate strength development, better riding quality, reduced maintenance requirement, increased pavement life. अब नीचे important point देखिए. Construction defects directly reduce pavement performance. And this is the reason why QA/QC is so important. Now let us look at the third topic. 3 major construction stages. What is flexible pavement construction sequence? Step 1. Subgrade preparation. Step 2. Granular layer construction. Step 3. Prime coat application. Step 4. Bituminous layer paving. Step 5. Compaction process. Step 6. Joint finishing. Step 7. Quality inspection. And this complete sequence is shown in the right side construction scene. Here hot mix plant, dumpers, paver machine, tandem roller, pneumatic roller, and water tanker are visible. And this is the actual field construction setup. Now let us look at the fourth topic. 4 subgrade construction considerations. Subgrade preparation में क्या important है? Proper compaction, moisture control, removal of soft spots, density achievement, surface level checking, drainage arrangement. Now see engineering warning below. Weak subgrade causes settlement and cracking. And pavement foundation failure starts from here. Now let us look at the fifth topic. 5 granular layer construction. What is important in GSB and WMM layers? Uniform material spreading, controlled moisture content, layer-wise compaction, cross-slope maintenance, thickness control, and proper gradation and density are very important for granular layer stability. Now let us look at the sixth topic. 6 bituminous layer construction. Which factors are critical in bituminous paving? Temperature control, proper mixing, uniform paving speed, proper rolling sequence, joint compaction, prevention of segregation. See the engineering note below. Temperature variation affects compaction and bonding quality. And temperature control is the most critical parameter in asphalt paving. Now let us look at the seventh topic. 7 compaction considerations. Here are the different types of rollers. Vibratory roller, tandem roller, pneumatic tire roller. Now look at the compaction objectives. Density achievement, air void reduction, strength improvement, prevention of deformation. And inadequate compaction is the biggest cause of pavement distress. Now let us look at the 8th topic. 8 segregation problem. What is segregation? When coarse and fine aggregates separate. So segregation develops. See its effects. Weak pavement zones. Uneven texture. Reduced durability. Water infiltration. Now look at the solutions. Controlled material handling. Uniform paving operation. Proper plant calibration. And the segregated surface is clearly visible in the right side image. Now let us look at the ninth topic. No joint construction considerations. Joint construction में क्या important है? Proper longitudinal joint compaction. Clean joint face. Temperature matching. Adequate overlap. Now see the engineering warning below. Weak joints become early failure locations. And longitudinal joint cracking is a very common problem in field projects. Now let us look at the 10th topic. WEATHER considerations during construction. In which weather conditions should construction be avoided? Heavy rainfall. Excessively low temperature. Strong wind conditions. Now see the important points below. Ensure dry surface condition before paving. And paving on a wet surface weakens the bonding. Now let us look at the 11th topic. 1. Drainage considerations. Why is drainage important during construction? Proper side drain provision. Prevention of water stagnation. Shoulder drainage control. Cross slope maintenance. See the engineering note below. Water infiltration is a major reason for pavement deterioration. And poor drainage rapidly reduces pavement life. Now let us look at the 12th topic. 1. Construction machinery used. Which machinery is used in flexible pavement construction? Hot mix plant. Sensor power. Vibratory roller. Pneumatic roller. Water tanker. Motor grader. Milling machine. And proper machinery selection improves construction quality. Now let's look at the 13th topic. 3 common construction defects. Low compaction. Surface undulation. Segregation. Improper joint finishing. Bleeding. Cracking. Raveling. And these failures develop due to improper construction practices. 4 Practical site observation. Delayed rolling reduces density achievement. Excess moisture weakens granular layers. Uneven paving speed creates surface irregularity. Improper temperature control affects bitumen bonding. And these are the issues that are most commonly seen during field inspection. Now let us look at the 15th topic. 15 QUALITY control requirements. What tests and checks are done in construction QC? Density testing. Temperature monitoring. Layer thickness checking. Bitumen content checking. Surface level verification. Gradation testing. Joint inspection. Smoothness testing. And proper QA/QC is what ensures a durable pavement. Now let's look at the 16th topic. 6 Interview question box. Q. Why is compaction important in pavement construction? Answer. Compaction improves density, strength, and pavement durability. Q. What is segregation in bituminous work? Answer. Separation of coarse and fine aggregates causing weak pavement zones. Now let's look at the additional concepts below. Temperature control. Mixing temperature. 160 degrees Celsius to 170 degrees Celsius. Laying temperature. 130 degrees Celsius to 150 degrees Celsius. Rolling temperature 90 degrees Celsius to 120 degrees Celsius. Now look at the cross-slope sequence. Proper rolling sequence ensures uniform compaction, and camber provides 2% to 3% drainage. Let's look at one short revision at the bottom. Proper compaction, strong pavement, poor drainage, pavement damage, segregation, weak zones, temperature control, better bituminous performance. Friends, if you want to learn highway construction, QAQC, pavement design, IRC standards and practical site engineering in such an easy way, so please subscribe to the channel and share the video as well, so that correct technical knowledge can reach the civil engineering community. See the final message at the bottom. Good construction practice, long-lasting pavement. And in the next slide, we will understand pavement failures and distress mechanisms in more detail. SLID 39, mnemonics and memory tricks. So friends, now we have reached a very interesting and highly useful revision slide. This slide is specially created for interviews, for Viva preparation, for quick revision, site for discussions. In this slide we have simplified IRC, SATI's flexible pavement concepts with the help of easy memory tricks and mnemonics. So let us understand the entire memory revision step by step. 1. Introduction to memory tricks. Mnemonics help in remembering engineering concepts quickly and improve fast recall during interviews, exams and site discussions. See the engineering note below. Concept clarity plus memory tricks improves technical confidence. And this is the smart way of technical learning. Now let us look at the second section. Though flexible pavement layer mnemonic. Mnemonic is given. Big dogs wear good shoes. Now let us understand its meaning. BBC, bituminous concrete. DDBM, dense bituminous macadam. WWMM, wet mix macadam. GGSB, granular sub-base. S subgrade, foundation layer. Now let us look at the third section. Teen pavement thickness memory trick. Shortcut rule. High traffic thick pavement. Low CBR thick pavement. Poor drainage early failure. Now see the engineering note below. Traffic and soil strength mainly control pavement thickness. And this is the basic engineering logic behind pavement design. Now let us look at the fourth section. 4MSA formula memory trick. This is the IRC SATI's traffic formula. N 365 times A times left frac 1 plus R N 1 R right times F times D. Let us understand its memory logic. A initial traffic. R growth rate. N design life. F vehicle damage factor. D lane distribution factor. Now look at the shortcut sentence. All roads need fast driving. ARNFD. With this sequence the formula will be easily remembered. Now let us look at the fifth section. Punch CBR memory trick. CBR means California bearing ratio. Shortcut concept. CBR soil strength. High CBR strong soil. Low CBR weak soil. Now look at the memory line below. Strong soil saves thickness. That means if there is strong soil, the pavement thickness reduces. Now let us see the complete pavement system memory map on the right side. एक BC राइडिंग सरफेस, 2 DBM लोड डिस्ट्रीब्यूशन, 3 WMM बेस लेयर, 4 GSB ड्रेनेज सपोर्ट, 5 सबग्रेड फाउंडेशन. And this is the complete pavement memory map. Now let us see the traffic loading concept. Axle load repetitions. Standard axles. MSA. And this is the design traffic concept. Now let's look at the common pavement failures mnemonic. Mnemonic. FRBPT. F fatigue cracking. R rutting. R raveling. B bleeding. P potholes. Now see engineering warning below. Water accelerates all pavement failures. And this is the main concept of drainage importance. Now let us look at the 7th section. Sat overlay design memory trick. Overlay purpose. Strengthening. Surface improvement. Life extension. Now look at the shortcut sentence. Old pavement gets new strength. Now let's look at overlay problems. Reflective cracking, debonding, rutting, and these are the overlay distress mechanisms. Now let us look at the 8th section. Art CTB and CTSB memory trick. CTB matlab cement treated base. Functions. Higher stiffness. Better load distribution. अब CTSB देखिए. CTSB matlab cement treated sub base. Functions. Stabilized support layer. Reduced deformation. See the engineering note below. Proper curing improves stabilized layer strength. And curing is very important in stabilized pavement. Now let us look at the 9th section. No compaction memory trick. Compaction effects. Higher density. Better strength. Longer life. Lower settlement. Now look at the shortcut sentence. Good rolling gives good roads. And this is the simplest concept of compaction. Now let us look at the 10th section. DRAINAG memory trick. Drainage importance. Prevent water infiltration. Protect subgrade. Improve pavement life. Now look at the shortcut line. No water, longer pavement life. Now see engineering warning below. Poor drainage weakens the entire pavement system. And this is the major reason for pavement deterioration. अब हाईवे मशीनरी मेमोरी ट्रिक देखते हैं. Mnemonic. PRNG. P paver. R roller. M motor grader. G generator or plant. And this is the major highway machinery sequence. Now let's see the quality control memory trick. Mnemonic. DTTGS. D density. T thickness. T temperature. G gradation. S smoothness. And this is the pavement QA/QC checklist. Now let's look at site observation memory tricks. Weak shoulder. Edge failure. Poor compaction. RUTTING. Excess moisture. Weak layers. Delayed maintenance. Bigger damage. And these are practical site engineering observations. Now let's see interview rapid recall tricks. MSA. Traffic loading. CBR. Soil strength. CTB. Stabilized layer. WMM. Load distribution. GSB. Drainage support. Overlay. Strengthening layer. And these are quick interview revision concepts. Now let's look at the final master shortcut box. Flexible pavement. Layered structure. Traffic. MSA. Soil strength. CBR. Compaction. Strength. Drainage. Protection. Quality control. Durability. IRC 37. Pavement Design Code. And this is the entire Flexible Pavement Engineering Master Summary. Now let's look at the practical site observation box below. Weak drainage accelerates cracking. Improper rolling reduces density. Low quality aggregates increase failures. Poor curing weakens CTB layer. And these are the actual highway field problems. Let's look at the final memory summary at the bottom. FRBPP. Pavement failures. DTTGS. Quality control. Big dogs wear good shoes. Pavement layers. Good rolling gives good roads. Compaction. No water, longer pavement life. Drainage. And this is a complete memory revision of the entire IRC 37 flexible pavement design. If you found this CI Master Revision series useful, so do subscribe to the channel. And now in the next final slide, we will go over the complete Flexible Pavement Master Summary and final closing revision. SLID 40. Final Quick Revision Master Summary Sheet. So friends, now we have reached the final and most important revision slide of this entire IRC 37 Flexible Pavement Design Series. This is ours. Final Quick Revision Master Summary Sheet. In this slide we have summarized the entire flexible pavement design in a complete quick revision format. Have understood this entire series properly. So the major concepts of IRC 37 pavement layers, failures, design logic, drainage, QAQC and site engineering concepts will be permanently clear to you. So let's revise the entire final master summary step by step. एक flexible pavement master concept. Flexible pavement is a multi-layer pavement system. Its main purpose is to distribute the wheel load safely to the subgrade. Now look below. Pavement performance depends on traffic on loading, on soil strength, on drainage, material quality पर, construction quality पर. अब engineering note देखिए. Strong design plus quality construction equals long pavement life. And this is the core concept of the entire field of pavement engineering. Now let's look at the second section. दो complete pavement layer summary. Top to bottom layers. एक BC. Bituminous concrete. Riding surface. 2 dBm. Dense bituminous macadam. Structural strength. 3 Wm. Wet mix macadam. Load distribution layer. 4 GSB. Granular sub-base. Drainage support layer. 5 subgrade. Foundation layer. And this is the complete pavement layer hierarchy. Now let us look at the third section. 3 IRC 37 Design Summary. Main design inputs. Design traffic. MSA. CBR. Design life. Vehicle damage factor. Drainage condition. Material properties. Now take a look at the engineering concept below. Higher traffic. Higher thickness. Lower CBR. Higher thickness. And this is the base logic of pavement thickness design. Now let us look at the fourth section. 4 Design Traffic Formula Summary. This is the IRC 37 design traffic formula. N 365 times A times left frac 1 plus R N 1 R right times F times D. Let us understand its terms. A initial CVPD. R growth rate. N design life. F vehicle damage factor. D lane distribution factor. N design traffic in MSA. And this is the main design equation of traffic analysis. Now let us look at the fifth section. Punch subgrade and CBR summary. CBR represents soil strength, bearing capacity, pavement support capability. Now look at the shortcut rule. High CBR thin pavement, low CBR thick pavement. Now see engineering warning below. Weak subgrade causes pavement distress. And this is the reason why subgrade investigation is very important. Now let us look at the master pavement structure on the right side. Wheel load is maximum at the top surface. And with depth the stress gradually decreases. That is why pavement layers provide load distribution. Now let us look at the sixth section. CTB and CTSB summary. CTB means cement treated base. Functions: higher stiffness, better load transfer, reduced pavement thickness. अब CTSB देखिए. CTSB मतलब cement treated sub base. Functions: stabilized support layer, improved foundation support, better moisture resistance. And this is the concept of stabilized pavement system. Now let us look at the seventh section. 7 overlay design summary. Overlay strengthens the existing pavement. But major overlay problems also occur. Debonding, rutting, reflection cracking. Now look below. Proper bonding is essential. And this is the importance of tack coat and surface preparation. Now let us look at the eighth section. Art pavement failure summary. Major pavement failures: fatigue cracking, rutting, bleeding, raveling, potholes. Now watch engineering warning. Poor drainage accelerates all pavement failures. And drainage failure is the biggest cause of pavement deterioration. Now let us look at the ninth section. No drainage master summary. Proper drainage is required. Cross slope, side drains, shoulder drainage, moisture infiltration control. See the engineering note below. Drainage protects pavement foundation. And this is the major factor in pavement life improvement. Now let us see the right side traffic loading concept. Axle load repetitions. Converted to standard axles. MSA. And this is the traffic design philosophy. Now let us see the comparison of CTB and CTSB. CTB provides structural strength. CTSB provides foundation support. And both are important in stabilized pavement systems. Now let us look at the 10th section. CONSTRUCTION and compaction summary. Good construction requires proper rolling sequence, uniform paving speed, temperature control, layer-wise compaction, proper joint finishing. Now look at compaction importance below. Better density, higher strength, longer pavement life. And this is the main concept of compaction engineering. Now let us look at the 11th section. 1 Quality Control Master Summary. Important QA/QC checks. density testing, thickness check, graduation testing, bitumen testing, temperature monitoring, smoothness checking, core cutting. Now take a look at the engineering concept below. Continuous testing better pavement quality. And this is the quality assurance philosophy. Now let us look at the 12th section. 1-2 Highway Machinery Summary. Major pavement machinery. Sensor power, vibratory roller, tandem roller, pneumatic tire roller, motor grader, hot mix plant, milling machine. And this is the complete highway construction machinery setup. Now let us look at the 13th section. 1-3 Most important IRC engineering concepts. Flexible pavement acts as layered structure. Wheel load stress decreases with depth. Bituminous layer resists tensile stress. Granular layer distributes wheel load. Strong subgrade increases pavement thickness support. Proper drainage improves durability. And this is the complete pavement engineering behavior. Now let us look at the 14th section. 1-4 Super Quick Revision Table. MSA. Traffic Loading. CBR. Soil Strength. CTB. Stabilized Base. WMM. Load Distribution Layer. GSB. Drainage Support. Overlay. Pavement Strengthening. Compaction. Strength Improvement. Drainage. Pavement Protection. And this is the final rapid revision table. Now let us look at the 15th section. 1-5 Practical Site Observation Box. Poor compaction causes rutting. Water infiltration weakens subgrade. Weak shoulders create edge cracking. Improper temperature affects bitumen bonding. Delayed maintenance enlarges pavement failures. And these are the actual site engineering observations. Now let's look at the 16th section. 1-6 Final Interview Rapid Fire Questions. Q. What mainly controls pavement thickness? Uns. Traffic loading and CBR value. Q. Why is drainage important? Uns. Drainage protects pavement from moisture damage. Q. What causes fatigue cracking? Uns. Repeated wheel loading and tensile stress. Q. Why is compaction important? Uns. Compaction improves pavement density and strength. And these are the most expected highway engineering interview questions. Now let us look at the 17th section. 1-7 Final Master Revision Box. Flexible Pavement. Layered Load Distribution System. Traffic. MSA. Subgrade Strength. CBR. Proper compaction. Durable pavement. Good drainage. Long pavement life. IRC 37. Flexible Pavement Design Guideline. Quality Control. Performance Assurance. And that's the whole IRC 37 Flexible Pavement Engineering philosophy. Let's look at the final closing engineering note at the bottom. Successful pavement design depends on proper traffic analysis, strong subgrade, adequate drainage, quality materials, and strict construction control. And this is the final master conclusion of complete highway pavement engineering. Congratulations friends. You have successfully completed IRC 37 Flexible Pavement Design Revision Series. If you found this CI Engineering Master Series useful, so do subscribe to the channel. Like it, share it, and stay connected with Civil Engineering Infrastructure channel. Because here we understand highway engineering, pavement design, QA/QC, IRC codes, MOA/TH specifications and real site engineering concepts in a practical way. Thank you engineers. Keep learning. Keep growing. Jai Hind. Thank you engineers. आज हमने कंप्लीट IRC 37 फ्लेक्सिबल पेवमेंट डिजाइन सीरीज सक्सेसफुली कंप्लीट कर ली है। इस पूरी सीरीज में हमने स्टेप बाय स्टेप समझा फ्लेक्सिबल पेवमेंट बेसिक्स, IRC 37 डिजाइन मेथडोलॉजी, ट्रैफिक एंड MSA कॉन्सेप्ट्स, CBR एंड सबग्रेड डिजाइन, CTB एंड CTSB, overlay design, drainage engineering, pavement failures, quality control, construction practices, important formula revision, interview preparation, Viva questions, memory tricks and quick revision. And this is the complete foundation of highway pavement engineering. Now the most important thing. Strong infrastructure begins with strong engineering knowledge. If you want to learn practical highway engineering, if you want to understand IRC standards properly, if you want to learn site execution, QA/QC, pavement design and real field engineering concepts, so stay connected with Civil Engineering Infrastructure IECI channel. Here we understand practical civil engineering in an easy and technical way. Now look at the right side pavement structure. Wheel load is maximum at the top surface, and stress decreases with depth. Flexible pavement design is based on this principle. Now remember pavement failure modes: fatigue cracking, rutting, bleeding, raveling, potholes. To control these failures it is necessary proper drainage, good compaction, quality materials, correct design thickness, strict construction control. See the laboratory and testing section below. Marshall stability test, CBR test, density test, core cutting, gradation analysis. And these tests are the backbone of pavement quality assurance. Now listen to the final professional engineering note. Engineering excellence is achieved through proper design, strict quality assurance, accurate execution, and continuous technical learning. Is the hallmark of a successful highway engineer. If this complete CI engineering series has been useful to you, so like the video, share it with your engineering friends, and do subscribe to CI channel, so that you continuously receive advanced practical knowledge related to highway engineering, pavement design, MOA/TH specifications, IRC codes, QA/QC, and site execution. Designed and presented by Rahul Pandey, Civil Engineering Infrastructure, CI. Let's build the future together. Learn more. Build better. Build stronger. Build the nation. Jai Hind.